Learning objectives. In this chapter, the user would be learning about .NET architecture and advanced tools and the following in detail. Object-oriented programming, creating distributed web applications, XML and ADO.NET, graphics, printing, reporting. .NET architecture and advanced tools. Object-oriented programming. Classes and objects. When you define a class, you define a blueprint for a data type. This doesn't actually define any data, but it does define what the class name means, that is, what an object of the class will consist of and what operations can be performed on such an object. Objects are instances of a class. The methods and variables that constitute a class are called members of the class. A class definition starts with the keyword class followed by the class name, and the class body is ended by the end class statement. Following is the general form of a class definition. Attribute list is a list of attributes that apply to the class, optional. Access modifier defines the access levels of the class. It has values as public, protected friend, and private, optional. Shadows indicate that the variable redeclares and hides an identically named element or set of overloaded elements in a base class, optional. Must inherit specifies the class can be used only as a base class and that you cannot create an object directly from it, that is an abstract class, optional. Not inheritable specifies that the class cannot be used as a base class. Partial indicates a partial definition of the class. Inherits specifies the base class it is inheriting from. Implement specifies the interfaces the class is inheriting from. The example demonstrates a box class with 3 data members, length, breadth, and height. When the code is compiled and executed, it produces the following result. Member functions and variables. A member function of a class is a function that has its definition or its prototype within the class definition like any other variable. It operates on any object of the class of which it is a member and has access to all the members of a class for that object. Member variables are attributes of an object from a design perspective, and they are kept private to implement encapsulation. These variables can only be accessed using the public member functions. Example program for set and get the value of different class members in a class. When the code is compiled and executed, it produces the following result. Constructors. A class constructor is a special member sub of a class that is executed whenever we create new objects of that class. A constructor has the name new and it does not have any return type. Types of constructor: default constructor, parameterized constructor. A default constructor does not have any parameter, but if you need, a constructor can have parameters. Such constructors are called parameterized constructors. This technique helps you to assign initial value to an object at the time of its creation. Example for constructor. When the code is compiled and executed, it produces the following result. Destructor. A destructor is a special member sub of a class that is executed whenever an object of its class goes out of scope. A destructor has a name finalized and it can neither return a value nor can it take any parameters. Destructor can be very useful for releasing resources before coming out of the program, like closing files, releasing memories, etc. Destructors cannot be inherited or overloaded. Example for destructor. When the code is compiled and executed, it produces the following result. Shared members of a VB.NET class. The keyword shared implies that only one instance of the member exists for a class. Shared variables are used for defining constants because the values can be retrieved by invoking the class without creating an instance of it. We can define class members as static using the shared keyword, declare a member of a class as shared It means no matter how many objects of the class are created, there is only one copy of the member. Shared variables can be initialized outside the member function or class definition. You can also initialize shared variables inside the class definition. Example for shared members of a VB.NET class. When the code is compiled and executed, it produces the following result. You can also declare a member function as shared. Such functions can access only shared variables. The shared functions exist even before the object is created. Inheritance. One of the most important concepts in object-oriented programming is that of inheritance. Inheritance allows us to define a class in terms of another class, which makes it easier to create and maintain an application. This also provides an opportunity to reuse the code functionality and fast implementation time. When creating a class, instead of writing completely new data members and member functions, the programmer can designate that the new class should inherit the members of an existing class. This existing class is also called the base class, and the new class is referred to as the derived class. Base and derived classes. A class can be derived from more than one class or interface, which means that it can inherit data and functions from multiple base classes or interfaces. The derived class inherits the base class member variables and member methods. Therefore, the superclass object should be created before the subclass is created. The superclass or the base class is implicitly known as MyBase in VB.NET. The syntax used in VB.NET for creating derived classes is as follows. The following program demonstrates this. When the code is compiled and executed, it produces the following result. Exception handling. An exception is a problem that arises during the execution of a program. An exception is a response to an exceptional circumstance that arises while a program is running, such as an attempt to divide by 0. In general, it handles the runtime error. Exception provides a way to transfer control from one part of the program to another. VB.NET exception handling is built upon 4 key words: try, catch, finally, and throw. Syntax. Try. A try block identifies a block of code for which particular exceptions would be activated. It's followed by one or more catch blocks. Catch. A program catches an exception with an exception handler at the place in the program where you want to handle the problem. The catch keyword indicates the catching of an exception. Finally. The finally block is used to execute a given set of statements, whether an exception is thrown or not thrown. For example, if you open a file, it must be closed whether an exception is raised or not. Throw. A program throws an exception when a problem shows up. This is done using a throw keyword. Exception classes in .NET Framework. In the .NET Framework, exceptions are represented by classes. The exception classes in .NET Framework are mainly directly or indirectly derived from the system.exception class. Some of the exception classes derived from the system.exception class are the system.applicationException and system.systemException classes. The system.applicationException class supports exceptions generated by application programs, so the exceptions defined by the programmer should derive from this class. The system.systemException class is the base class for all predefined system exception. Some of the predefined exception classes: system.io exception, system.indexOutOfRange exception, system.ArrayType mismatch exception, system.nullReference exception. Handles I/O errors. Handles errors generated when a method refers to an array index out of range. Handles errors generated when type is mismatched with the array type. Handles errors generated from differencing a null object. System.divideByZero exception, System.invalidCast exception, System.outofmemory exception, System.stackoverflow exception. Handles errors generated from dividing a dividend with 0. Handles errors generated during typecasting. Handles errors generated from insufficient free memory. Handles errors generated from stack overflow. Handling exceptions. VB.NET provides a structured solution to the exception handling problems in the form of try and catch blocks. Using these blocks, the core program statements are separated from the error handling statements. These error handling blocks are implemented using the try, catch, and finally keywords. Following is an example of throwing an exception when dividing by 0 condition occurs. When the code is compiled and executed, it produces the following result. You can use a throw statement in the catch block to throw the present object as throw expression. Example. You can throw an object if it is either directly or indirectly derived from the system.exception class. Creating distributed web applications. Visual Studio.NET provides the tools you need to design, develop, debug, and deploy web applications, XML web services, and traditional client applications. Visual Studio.NET provides information on application design decisions, such as system architecture, database design, and international considerations, as well as enterprise templates. Application architects can use the .NET platform to develop, deploy, and support distributed applications. Highly integrated but flexible, this platform enables developers to build end-to-end business solutions that can leverage existing architectures and applications. Windows DNA was an architecture linked tightly coupled distributed web applications. As distributed applications began to require more loosely coupled principles, the Microsoft architecture moved to the .NET platform. Developers can build highly scalable and flexible applications by partitioning applications along these lines, by using component-based programming techniques, and by fully using the features of the .NET platform and the Microsoft Windows operating system. A simple distributed application model consists of a client that communicates with the middle layer, which itself consists of the application server and an application containing the business logic. The application, in turn, communicates with the database that supplies and stores data. The key tenet of distributed applications is the logical partitioning of an application into 3 fundamental layers: presentation, business logic, data access, and storage. Presentation services. The presentation layer includes either a rich or thin client interface to an application. The rich client, either directly by using the Microsoft Win32 API or indirectly through Windows Forms, provides a full programming interface to the operating system's capabilities or uses components extensively. The thin client web browser is rapidly becoming the interface of choice for many developers. A developer is able to build business logic that can be executed on any of the 3 application tiers. With ASP.NET Web Applications and XML Web Services, the thin client is able to provide a visually rich, flexible, and interactive user interface to applications. Thin clients also have the advantage of providing a greater degree of portability across platforms. Business logic, application services. This layer is divided into application servers and services, which are available to support clients. Web applications can be written to take advantage of COM+ services, message queuing, MSMQ, directory services, and security services using the .NET framework Application services, in turn, can interact with several data services on the data access layer. Data access and storage services. The data services that support data access and storage consists of ADO.NET, which provides simplified programmatic access to data by using either scripting or programming languages. OLEDB, which is an established universal data provider developed by Microsoft. XML, which is a markup standard for specifying availability. All applications are available at least some of the time, but web-based applications and mission-critical enterprise applications must typically provide round-the-clock services. If your enterprise application needs to work 24 hours a day, 7 days a week, you probably need to design for high availability. Advances in hardware and software have dramatically increased the quality of high availability applications. However, availability is not easy to implement and requires considerably more complex architectural infrastructure than the previous generation of client-server applications. If your application requires high availability, you will want to understand how design choices help maximize application availability and how testing can validate planned service levels. Reduce unplanned downtime. Cluster service with a shared disk avoids most downtime and provides automatic recovery from hardware or software failures. Reduce planned downtime. Planned downtime is reduced because you can deploy operating system and application upgrades without interrupting normal service by using a rolling upgrade. Continuous health monitoring. The operational status of your application and server is automatically checked. When a problem is identified, the failed service is transferred to another server. Manageability. Managing a modern .NET application requires an efficient way to handle typical local and remote application support processes, including initial deployment, configuration tuning, scheduled and unscheduled maintenance, management agents. Each hardware device, operating system device, and application service requires a management agent. Management agents monitor the local resource and publish data about the resource's current state and performance. Collection process. The information collection process collects, filters, correlates, and stores information from all of the management agents. Management console. The Management Console workstation aggregates and reports in application management information. From this central console, an administrator can monitor all devices, analyze operational profiles, automate certain recurring activities, receive notifications from managed elements, and initiate remote configuration changes. Performance. Identifying constraints, determining features, specifying the load. Key application metrics such as transaction throughput and resource utilization define application performance. Metrics related to hardware such as network throughput and disk access are common application performance bottlenecks. From a user's perspective, application response time defines performance. Of course, performance does not come without a price. While it is possible to build a high-performance application for any given problem space, a key price point is a cost per transaction. It is sometimes necessary to sacrifice performance to control cost. Reliability. As distributed applications grow both in size and complexity, there is an increasing need to improve the reliability and operating quality of software. First, the cost of application failure is often too high. Users bypass unreliable websites, resulting in lost revenue and reduced future sales, and the expense of repairing corrupted data can further increase the cost of application failure. Second, unreliable systems are difficult to maintain or improve because failure points are typically hidden throughout the system. Finally, modern software technology makes it easy to create reliable applications. At its best, good reliability design engineering would follow the Windows 2000 application design guidelines, put reliability requirements in the specification, use good architectural infrastructure, build management information into the application, use redundancy for reliability, use quality development tools, use built-in application health checks, use consistent error handling. Scalability. Scalability is the capability to increase resources to yield a linear increase in service capacity. The key characteristic of a scalable application is that additional load only requires additional resources rather than extensive modification of the application itself. Although raw performance makes a difference in determining the number of users that an application can support, scalability and performance are two separate entities. In fact, performance efforts can sometimes be opposed to scalability efforts. The 5 commandments of designing for scalability: do not wait, do not fight for resources, design for commutability, design for interchangeability, partition resources and activities. Securability. The ability to provide security to an application and its data is referred to here as securability. The securability of an application is impacted by numerous design choices, such as the selection of communication protocols and the method of user authentication. Most security vulnerabilities are not in security-related code. Instead, they are found in code that is unrelated to security and that was written without attention to security. This is why developers must be keenly aware of application securability. At Microsoft, the acronym STRIDE is used to describe the following taxonomy of security threats. S for spoofing identity, T for tampering with data, R for reputability, I for information disclosure, D for denial of service, E for elevation of privilege. XML. Extensible Markup Language is the universal format for data on the web. XML allows developers to easily describe and deliver rich, structured data from any application in a standard, consistent way. XML does not replace HTML, rather it is a complementary format. The Extensible Markup Language, XML, is a markup language much like HTML or SGML. This is recommended by the World Wide Web Consortium and available as an open standard. The System.xml namespace in the .NET framework contains classes for processing XML documents. XML class. XML attribute represents an attribute. Valid and default values for the attribute are defined in a document type definition, DTD, or schema. XML C data section represents a C data section. XML character data provides text manipulation methods that are used by several classes. XML comment represents the content of an XML document. XML class. XML convert encodes and decodes XML names and provides methods for converting between common language runtime types and XML schema definition language XSD types. When converting data types, the values returned are locale independent. XML declaration represents the XML declaration node, open tag, question XML, version equals 1.0, question, close tag. XML dictionary implements a dictionary used to optimize Windows Communication Foundation WCF's XML writer implementations. XML class. XML dictionary reader, an abstract class that the Windows Communication Foundation derives from XML reader to do serialization and deserialization. XML dictionary writer represents an abstract class that Windows Communication Foundation derives from XML writer to do serialization and deserialization. XML document represents an XML document. XML document fragment represents a lightweight object that is useful for tree insert operations. XML class. XML document type represents a document type declaration. XML element represents an element. XML entity represents an entity declaration, such as open tag, exclamation, entity, close tag. XML entity reference represents an entity reference node. XML exception returns detailed information about the last exception. XML implementation defines a context for a set of XML document objects. XML linked node gets the node immediately preceding or following this node. XML class. XML node represents a single node in the XML document. XML node list represents an ordered collection of nodes. XML node reader represents a reader that provides fast, non-cache forward-only access to XML data in an XML node. XML notation represents a notation declaration such as open tag, exclamation, notation, close tag. XML parser context provides all the context information required by the XML reader to parse an XML fragment. XML class. XML processing instruction represents a processing instruction which XML defines to keep processor-specific information in the text of the document. XML qualified name represents an XML qualified name. XML reader represents a reader that provides fast, non-cached, forward-only access to XML data. XML reader settings provides a set of features to support on the XML reader object created by the create method. XML class. XML resolver resolves external XML resources named by a Uniform Resource Identifier, URI. XML secure resolver helps to secure another implementation of XML resolver by wrapping the XML resolver object and restricting the resources that the underlying XML resolver has access to. XML significant white space represents white space between markup in a mixed content node or white space within an XML : space equals preserved scope. This is also referred to as significant white space. XML class. XML text represents the text content of an element or attribute. XML text reader represents a reader that provides fast, non-cached, forward-only access to XML data. XML text writer represents a writer that provides a fast, non-cache, forward-only way of generating streams of files containing XML data that conforms to the W3C extensible markup language XML 1.0 and the namespaces in XML recommendations. XML white space represents white space in element content. XML class. XML URL resolver resolves external XML resources named by a Uniform Resource Identifier, URI. XML writer represents a writer that provides a fast, non-cached, forward-only means of generating streams or files containing XML data. XML writer settings specifies a set of features to support on the XML writer object created by the XML writer.create method. ADO.NET. ADO.NET provides a bridge between the front-end controls and the back-end database. The ADO.NET objects encapsulates all the data access operations, and the controls interact with these objects to display data, thus hiding the details of movement of data. ADO.NET provides consistent access to data sources such as SQL Server and XML and data sources exposed through OLEDB and ODBC. Data sharing consumer applications can use ADO.NET to connect to these data sources and retrieve, handle, and update the data that they contain. The ADO.NET classes are found in the system.data.dll and are integrated with the XML classes found in the system.xml.ell. Sample code connects to a database, retrieves data from it, and then displays that data in a console window. The dataset class. The dataset represents a subset of the database. It does not have a continuous connection to the database. To update the database, a reconnection is required. The dataset contains data table objects and data relation objects. Properties of the dataset class. Case sensitive indicates whether string comparisons within the data tables are case sensitive. Container gets the container for the component. Dataset name gets or sets the name of the current data set. Default view manager returns a view of data in the dataset. Design mode indicates whether the component is currently in design mode. Enforce constraints indicates whether the constraint rules are followed when attempting any update operation. The dataset class. Methods of the dataset class. Events gets a list of event handlers that are attached to this component. Extended properties gets a collection of customized user information associated with the dataset. Has errors indicates if there are any errors. Is initialized indicates whether the dataset is initialized. Locale gets or sets the locale information used to compare strings within the table. Namespace gets or sets the namespace of the dataset. The data table class. The data table class represents the tables in the database. It has the following important properties. Child relations returns a collection of child relationship. Columns returns the columns collection. Constraints returns the constraints collection. Dataset returns the parent dataset. Default view returns a view of the table. Parent relations returns the parent relations collections. Primary key gets or sets an array of columns as the primary key for the table. Rows returns the rows collection. The data row class. The data row object represents a row in a table. It has the following important properties. Has errors indicates if there are any errors. Items gets or sets the data stored in a specific column. Item arrays gets or sets all the values for the row. Table returns the parent table. The data row class. The data adapter object. The data adapter object acts as a mediator between the data set object and the database. This helps the data set to contain data from more than one database or other data source. The data reader object. The data reader object is an alternative to the data set and data adapter combination. This object provides a connection-oriented access to the data records in the database. DB command objects. The DB connection object represents a connection to the data source. The connection could be shared among different command objects. DB connection objects. The DB command object represents the command or a stored procedure sent to the database from retrieving or manipulating data. Graphics control. Graphics. It is a top-level abstract class for all graphics contexts. Graphics 2D. It is a subclass of graphics class and provides more sophisticated control over geometry, coordinate transformations, color management, and text layout. Arc2D. Arc2D is the abstract superclass for all objects that store a 2D arc defined by a framing rectangle, start angle, angular extent, length of the arc, and a closure type, open, chord, or pi. Cubic curve 2D. The cubic curve 2D class is the abstract superclass for all objects which store a 2D cubic curve segment, and it defines a cubic parameter curve segment in x-y coordinate space. Graphics control. Ellipse 2D. The ellipse 2D is the abstract superclass for all objects which store a 2D ellipse, and it describes an ellipse that is defined by a framing rectangle. Rectangle 2D. The rectangle 2D class is an abstract superclass for all objects that store a 2D rectangle, and it describes a rectangle defined by a location x, y, and dimension w, x, h. Quad curve 2D. The quad curve 2D class is an abstract superclass for all objects that store a 2D quadratic curve segment, and it describes a quadratic parametric curve segment in xy coordinate space. Graphics control. Line 2D. This line 2D represents a line segment in xy coordinate space. Font. The font class represents fonts which are used to render text in a visible way. Color. The color class is used to encapsulate colors in the default sRGB color space or colors in arbitrary color spaces identified by a color space. Basic stroke. The basic stroke class defines a basic set of rendering attributes for the outlines of graphics primitives, which are rendered with a graphics 2D object that has its stroke attribute set to this basic stroke. Printing. The print dialog control lets the user print documents by selecting a printer and choosing which sections of the document to print from a Windows Forms application. There are various other controls related to printing of documents. The print document control. It provides support for actual events and operations of printing in Visual Basic and sets the properties for printing. The printer settings control. It is used to configure how a document is printed by specifying the printer. The page setup dialog control. It allows the user to specify page-related print settings, including page orientation, paper size, and margin size. The print preview control. It represents a raw preview part of printing previewing from a Windows Forms application without any dialog boxes or buttons. The print preview dialog control. It represents a dialog box form that contains a print preview control for printing from a Windows Forms application. Print dialog control. The following are some of the commonly used properties of the print dialog control. Allow current page. Gets or sets a value indicating whether the current page option button is displayed. Allow print to file. Gets or sets a value indicating whether the print to file checkbox is enabled. Allow selection. Gets or sets a value indicating whether the selection option button is enabled. Allow some pages. Gets or sets a value indicating whether the pages option button is enabled. Print dialog control. Document. Gets or sets a value indicating the print document used to obtain printer settings. Printer settings. Gets or sets the printer settings the dialog box modifies. Print to file. Gets or sets a value indicating whether the print to file checkbox is selected. Show help. Gets or sets a value indicating whether the help button is displayed. Show network. Gets or sets a value indicating whether the network button is displayed. Printing methods. Reset. Resets all options to the default values. Run dialog. When overridden in a derived class, specifies a common dialog box. Show dialog. runs a common dialog box with a default owner. Reporting. Designing the report. In this step, we create the JRXML file, which is an XML document that contains a definition of the report layout. We can use any text editor or iReport Designer to manually create it. If iReport Designer is used, the layout is designed in a visual way, hence the real structure of the JRXML can be ignored. Compiling the report. In this step, JRXML is compiled in a binary object called a Jasper file, star.jasper. This compilation is done for performance reasons. Jasper files are what you need to ship with your application in order to run the reports. Reporting. Executing the report. Filling data into the report. In this step, data from the application is filled in the compiled report. The class net.sf.jasperreports.engine.jasperFillManager provides necessary functions to fill the data in the reports. A Jasper print file, star.jarprint, is created, which can be used to either print or export the report. Exporting the report to desired format. In this step, we can export the Jasper print file created in the previous step to any format using Jasper Export Manager. As Jasper provides various forms of exports, hence, with the same input, we can create multiple representations of the data. Conclusion. In this chapter, the user would have learned about .NET architecture and advanced tools and the following in detail. Object-oriented programming, creating distributed web applications, XML and ADO.NET, graphics, printing, reporting.